So, it was working. Oh, yeah, yeah. Okay, here we go. Hey, it is on. Okay, I will use probably. Here we go. Okay, here we go. So let me start with a little bit of introduction. By my first name, last name, you can kind of guess that I'm Russian. So I was born and raised in Soviet Russia, and hopefully I made it to the land of free people here. So I didn't like it. Cannot recommend. What I'm doing right now, I am the director of engineering in one of the companies that used to be part of Motorola. It's called Cambium Networks. We are doing all sorts of wireless stuff. So I'm consider myself as a wireless guy mainly, but I'm very deep into the cybersecurity and securing those devices that we are making. So one other thing about me, yeah, I was sued by one of the multi-million-dollar companies for the reverse engineering. Oops. So let's get to the topic of presentation. So today I would like to talk about software bill of materials. Surprisingly, it is a very, well, I don't think we have enough coverage for this topic. There is a lot of discussions about supply chain attacks. So what is supply chain attack? We are getting the software, we're getting the hardware. In our case, we are doing wireless devices, networking devices. We're getting it from suppliers, right? And typically it's like a long chain of the suppliers, starting from the chipset vendors, then you have the SDKs, you have the intermediate software companies doing their own IP, selling it to the software companies. There is tons of open source stuff, and it all getting all together and resulting in the end product. And on each of those steps, right, it can be compromised. So there is a lot of discussions about the supply chain. Just a reminder, probably you've heard about all these cases, but they were all over the news as the supply chain hacks the SolarWinds, right? When the companies were getting these SolarWinds monitoring system, and it was compromised somewhere at SolarWinds, and as a part of the software updates, it was delivered, this malware was delivered to the to everybody, to the government agencies, to the municipalities, big enterprises, everybody. So it was a good example of the supply chain attack. Another, again, it was all over the news, the Log4j. It's an open source library for Java to do the logging, and apparently it was used by the myriad of different enterprise systems as a small open source portion inside them. And another example is the dependency confusion. Again, it was in the news a little bit. And the story is the following, that some companies, especially bigger IT companies like Meta, Microsoft, etc., they obviously have internal repositories with the artifacts, with the libraries, and so they have their own repositories. If somehow you know the package names in their like Python library names, if you know like NPM library names inside those companies, you can go and register in the public repositories the same library with the same name. And if they don't control their supply chain correctly, they will download your version instead of the internal version of the library. So there was a good example of this dependency injection when one guy registered a bunch of the, I think it was for Meta, he registered a bunch of the modules with the same names, and they were eventually used by the build system in there. So how all these examples brings us to the software bill of materials. Oh, that's another good example. I love this story. So the XZ utility, and I guess it was a blessing that it was caught, I guess. So everything started with the open source project called XZUtils. It is a compression library used by the whole variety of different open source programs, especially like OpenSSH. And one of the bad actors, somewhere in Asia, I guess, became the maintainer of this library. He was doing the pull requests on the GitHub, helping the project, supporting the project, especially things that everybody considers boring, like a build system. So he was helping with the build system, with the configuration scripts, and eventually he get the trust of the maintainers and he get all the rights of the maintainer. So he created a pull request with the changes that are making things better as usual, and it was merged. It was merged in the upstream, and hopefully one of the Microsoft guys, he was looking at the sudden spikes of the CPU usage after he used this version, after he basically updated from the upstream different libraries. And eventually he found that there was a malware, but it was completely luck that he was actually paying attention, that he decided to unravel the whole chain. And what can possibly happen? That the bad actor basically planting the malware in the open source library that everybody are using. It's OpenSSH. It's everywhere. It's on all the servers, right? So we've been lucky that we caught it. So how it brings us to the story of the software bill of materials. I like this XKCD strip that all the modern infrastructure, if you look at any devices around us, any software around us, it's piled up on the on ton of open source, on ton of different libraries. And many times we have, yeah, this one guy from Nebraska or from Iowa supporting this small little library that everybody are using. And the worst part of it, that we don't really know, we don't really track where this specific library, where this piece of software is actually used. If you remember, if we go back to the log4j, the problem with the log4j, it wasn't that the library is vulnerable, because nobody knew where it actually is. And I bet that there are still systems running the vulnerable version of the log4j because nobody actually knowing that it's there. Because it was integrated in the software that you're buying from your supplier, and you don't really know that log4j is there. So a little bit of statistics. So Black Duck, it used to be Synopsys. Now I believe they call them Black Duck again. If you don't know, that's the company who is doing a lot of the, they have a product to scan your software code base and check what type of the open source stuff you are using. Very well-known software in this little industry. And they do these very nice reports on the open source software and how it is used. So here are the results. You probably cannot read it, but I will try to explain what's shown here. So it shows the code base containing open source in different industries. And it all starts with the stuff like aerospace, 100%. So meaning that 100% of the code bases that Black Duck was used for and what they've seen is actually using at least one open source project. So, and the same the blue one is the amount of the, if we take the whole code base, which amount of this code base is actually open source. So you can see that 69% is open source and only 31% is closed, meaning proprietary. That was developed in-house. So the majority of the code in the industries that we consider like the top-notch, we have certain expectations. Well, not after Boeing, but in general, we used to have high expectations of the industry. It's 69% open source. And you can go through all different industries and you can see how much is open source used. A little bit more statistics from the same report. So 96% contain open source. That's the average across all different industries. And not surprisingly enough, 84% contain at least one vulnerability in this open source stuff. So that's the reality that we are facing every day. You cannot get away from it. So let's talk what we can do with this. So the traditional approach to solve this problem is at least to have so-called software bill of materials. To collect all the packages, all the open source and closed source stuff that contained in your product or the product that you use. So the software bill of materials is the list of all the components. So how it helps? It helps with the transparency. So we know what exactly is there. If it's log4j, we know that it's there. If it is this XZ library, and then if we read it in the news, oh, it was compromised, we know that our software contains it, and now we know that we have to fix it, and that we know that we need to patch it. And by we, I mean everybody who are involved in the supply chain, from the chipset or from the low-level hardware to the end user. The next thing is so the vulnerability tracking, it helps. The other thing is compliance. So you can ask, oh, aerospace, they should have at least some compliance requirements, right? They should know. So there is a compliance pressure. So speaking of the compliance, so what type of compliances we have around it? It's, well, nobody likes compliances, I guess, but what we have around software bill of materials. The number one thing is the executive order with the long number as usual. And the idea of this executive order that if you sell anything, any product to the government agencies, like Department of Defense, etc., you have, as a vendor, you have to supply them with the software bill of materials. That's a requirement. So you cannot go away from it. You have to fulfill it. But it's applicable only to the specific industries, only to specific like government agencies. The same initiative, there is the same initiative in the European Union. So the same if you are selling it to the government, you have to supply software bill of materials. There are other initiatives. There is an initiative from NIST. It's more like a recommendation, as everything what NIST is doing, so it's not a requirement. Then we have NTIA. That's another agency here in US. They came up with a really nice guideline. So again, it's a recommendation, it's a framework that all the like device manufacturers, and I'm from the device manufacturer, that we have to follow. But again, it's a recommendation. So it's not a requirement. They kind of, you better do this. How many are actually doing this? A whole different question. So NTIA is doing this. Um, so who else? FDA. FDA has a strong requirement for the medical devices. So for the medical devices, surprisingly, they have a very strict requirement that the device manufacturer have to supply the software bill of materials. So if you are getting any medical device, you can request, and they have to provide it because that's not a recommendation; it's a requirement. Then we have CISA. They are doing a lot about software bill of materials. They have an event, actually it's in October, I think, the first week of October. I think it's already passed. They call it SBOM. They are getting all together and discuss the tools, how they can help creating it, what about the governance. So it's like a whole event just focused on the software bill of materials. And if you are interested in the topic, they have really nice slides and you can get more information about it. Last but not least, good old Linux Foundation, and they are trying to lead this activity because they understand the problem in the open source world. So again, what they are doing, they are coming up with their own standards. They are coming up with their own tooling. Tooling is free because it's Linux. So it's another initiative. So the good thing about the software bill of materials these days that it's becoming more of a best practice rather than the governance. Because again, it's all started as a governance, like, oh, you have to do this. But what we are seeing right now, especially for the larger IT organizations, as somebody said yesterday, that are above the security poverty line, who can afford it, they are doing the software bill of materials tracking on themselves. And we are seeing that chipset manufacturers, for example, they are doing the same on their side. So you can go there and ask them, oh, what's your SDK? And they will, what's in your SDK? And they will provide you a nice software bill of materials. And they are doing it by themselves without specific governance. I don't know if you can see the slide. This is from NIST. They have this nice diagram illustrating the life cycle of the software bill of materials. That it all starts. So there are different parts in the supply chain and different steps of the process. So obviously it starts with the plan. So in the plan we have a spec. We have certain requirements. So it is a starting point for the bill of materials. Then we have a third-party stuff. So we buy the third-party libraries or we use open source libraries. So here we go. That's the next step. The next step we actually develop. We write our own code if we are the supplier. So here is the supplier part, here is the user part. So we write our own code. Then we're getting to the build. And during the build phase, we can have different compilers. We can have different tools used. We can have some code generation during the build phase. So we have to track it as well. Then we're getting to the certification of all sorts, from FIPS to the Department of Defense. And we may want to freeze our bill of materials and say, okay, that was certified for this specific list of software. Then we're getting to the final package, when we have the final application and we can add additional metadata. And last but not least, as a part of this list, we need to understand the configuration. So how the application is used, what is the application configuration. So how we can capture all this information at different stages from the supplier to the user, especially when we do like a Docker containers, we have different sorts of the applications, how we can capture all this information, and there are file formats. So it boils down to the file formats. And there are three, at least for now, there are three popular formats for the bill of materials. So SPDX, Cyclone DX, and the SWID. So speaking of these formats, SPDX is coming from the Linux Foundation. So Linux Foundation is pushing this format as the main one for the adoption. So SWID is coming from NIST, and it is more focused on the from the deployment standpoint, meaning from the end user. So they are more looking at the end user use cases. And then there is a Cyclone DX. It started under OWASP initiative, and again, it's open. There are many companies, big companies, are contributing to this standard. I think it's becoming probably the most popular one outside of all of them, because initially it was, because it started by OWASP, it was focused on the security. So it has the security in mind as its core, but with all the extensions, it can have all different metadata inside. And right now, everybody are talking about AI. So they have the AI extension, so you can, for example, track your large language models as the part of your supply chain. So what type of the large language models are bundled into your software, and there is a special extension in the Cyclone DX to do this. So the core principle of the bill of materials is the unique identifier, because you have a bunch of different software listed, and you have to identify it, especially if it is like open source or third party. You have to reference it somehow. So there, inside all three formats, you can use different identifiers, and these are the most common ones. So the CPE Common Platform Enumerator, probably you saw that. If you go to the websites listing all the CVEs, you probably saw this identifier. Then there is like a package URL. These are the identifiers from the repositories, like with the Python modules, with the Maven for Java, with the NPM for all the JavaScript, TypeScript libraries. So you can have the unique identifier looking like this. So these are the most popular ones. This one is uniquely for Java stuff. And that's where we are coming to this tricky question. We have different identifiers that can be used. So how we map them all together? How we match them? Are they unique? Are we actually referencing this third party correctly? When it comes to the software numbers, is it like this format or this format? Are we getting it correctly? So it's all easily getting very messy. The other thing, so Linux Foundation, because it's open source and they are always very focused on the licensing and how open source is used, many of those formats, they also and lists, they contain the information about licensing. So for all the packages, you are getting its unique license. And I will show you the examples of how it looked like, but again, by the end you can get like 100 of different licensing. You can ask, oh, do we have so many open source licenses? Yes, we do. We have tons of different open source licenses, and in this, it can help us to track all of them. So what are the tools? The tools, they get into different type of groups, depending on your use case. So the first one, it is used by the supplier to generate the software bill of materials, basically to list all the software, to collect, to scan all your source base and generate the list. So that's the generation. Then, especially if you have to follow like FDA compliance, you have to verify that you actually meet the requirement. So you have to verify the bill of materials. So there are a bunch of tools, most of them are open source, by the way. They will help you to verify that you're actually meeting it. You're giving your bill of materials to the tool, and it tells you, okay, you're compliant. You have all the metadata, it looks okay. Then you have the modify merge tools, meaning when you have your device manufacturer, you are getting chipsets, different chipsets in your device. You are getting different SDKs. So now you want to merge it. You're using two different chipsets, you want to merge the list. You have to create the resulting product. So there are tools to merge those. Now we're getting to the ones on the right. It's more for the users, so not for the suppliers. To do the diff, to see the difference between SBOMs, when it can be useful, when you have a different version. So supplier is giving you a different version of the software or a different device. You would like to see what's different. Do we have any new components? If there are any software versions updated inside, so you can see like visually the diff. Then we have the whole bunch of translation tools. As you saw, there are at least 3 different standards with the 4 different software identifier types. You probably would like to standardize it inside your organization, either your supplier or you are the user, and have it in the same format. So if one supplier is giving you SPDX, another one is giving you Cyclone DX, you probably would like to convert one to another. So there are a bunch of tools that translates from one standard to another standard and helping you to fill the software identifiers. And the last one is to visualize it, because by the end of the day, all those files, it's like a long JSON or XML or it's a text file. So you cannot actually read it. It's not human readable. It's supposed to be machine readable, but not human readable. So there are a bunch of tools that helps you to visualize them. So, and that's how it looks like. Again, you cannot probably read it. It's low res, but it's a Cyclone DX example. So it's a JSON. It has different fields, like the version, like this spec version, the vendor name, the package names. Again, the references, you see it's reference to the NPM. And this one, this is example for the Proton Mail user client. So if you know what is Proton Mail, it's like a secure mail service, and they are trying to be open, and they trying to provide as much information as they can about what's going inside their software. It's open source, so they also provide the list of the bill of materials of all the packages they use. So you can look at this. That's another one that is difficult to read, but I will try to go through this. So with all this thing, because it's supposed to be machine readable.
I forget what you mentioned, like the AI hallucinations and kind of.
So, uh,
Giving
by the
you
way,
one result,
we're good with text.
which is not what the
So-
not AI, but the engine was supposed to do, is give you plural results, and it would give you one. So
Yeah.
is there any whatever
Okay.
they
So these are the tools that are probably the most common tools and
want to
most,
put?
most commonly used. So the first one is like a CLI tool. That's from OWASP originally. It can help you to generate the bill of materials for different projects.
A Google whacking was popular in '96 to maybe 2000. Thank you, my phone, for recognizing that. And it was definitely a method to disrupt the early Google machine. So it was more of a question than a.
If you poison the training corpus that's used to feed the model
I love it.
with, you can associate improperly. So yeah,
It's like
the classic
getting in and
whack
getting out,
was
feels like.
you do a link with the link text, litigious bastards, and it goes.
I will talk over. Okay, so the list of tools, I will probably not focus on those tools. You can Google them. So the next thing, when it gets to the security, software bill of materials, typically it doesn't have the information about like CVEs, obviously, because it's constantly changing thing. So what you can do, and that's another set of tools that you can get the software bill of materials, and you can use tools to cross-check it with the different databases like NVD database for the vulnerabilities. And there are a bunch of open source tools. I think I have it here somewhere. Yeah, like the dependency track can help with this. To show you the vulnerable packages. Just to give you the idea what we do, that's example from my organization, what we are doing, what we are eventually getting as the bill of materials and what we provide to our customers. And that's the Power BI dashboard that we are using for one of our products. So you can see all different variations of open source licensing, and then we have all the different packages. That's the visualization of the software bill of materials. So we have this dashboard, and obviously we have the dashboards for the security. So we are checking those packages against known vulnerabilities, and that's what we are getting. So probably that's where we are having all the challenges. So it's all good on paper. The software bill of materials, we have it. We have all the metadata. What are the challenges? So the first one is the obvious one. We have different identifiers, different systems using different identifiers. Big problem. Another one, mapping these software identifiers to the CVEs. If you read any CVE, it's difficult to understand if this CVE is applicable to this specific version or to this specific software, and even which software it's applicable. If you go to the database, I think, I don't remember the exact statistics, but like 30% of all the CVEs have like a unique software identifier, meaning it is not directly applicable to the well-known software. Then we have incomplete information from suppliers. Again, many times it's a governance, so it's like a checklist. We did it, we fulfill the governance requirements. That's it. We don't care. Then we lack build configuration, and that's another problem because with the open source and even the closed source, you can compile certain features, especially for the large like libraries or large packages. You can compile certain features or you can remove certain features. So, and you can be vulnerable if you compiled them, and you will be not vulnerable if you don't have them. Like a Linux kernel, a good example. There are thousands of modules and thousands of the CVEs, which may not be applicable to your specific device or your specific use case because you don't even compile those modules. So we don't have it as the part of the bill of materials, so it's challenging to track. And it's causing tons of the false positives. And the last one is it's difficult to track if you patch the vulnerability because you can backport and patch one specific vulnerability, right? And how you can track it right now in your bill of materials because it will be always a red flag like, oh, you have this CVE with the score 10 out of 10. So that's another challenge. And the last but not least, everything that I mentioned, it's from the supplier user perspective. It's all good. But for the bad guys, is the unique source of information, right? You are giving them like what's inside. So they can easily find what's vulnerable, right? That's why many of the companies, they are not giving it away on their website. You have to be part of some sort of the agreements, right? You go to the support, you ask for this, and then they will provide it. So they are trying to keep it secret and not publish it on everywhere. And with this, that's it.
Very good. Well, thank you, speaker, and then we'll have some questions.
Test, test.
Anyone have a question?
Good morning, and thank you for your talk. With software bill of materials, I know that the federal government and most other governments, they purchase from companies, but how can someone who works in the federal government access those SBOMs so that we can secure them and work with third parties?
Typically, so if you have any sort of the support access, you typically go to support and you request it. So you open up a ticket and ask, and they will give it to you. Like I want this software bill of materials, they will give it to you. And even with the guys like Microsoft, by the way, they are also providing it for the because they do a lot of open source things these days. So you can ask them as well. And obviously guys like Red Hat and other suppliers, IBM, Oracle, they are doing this.
Is this presentation available online?
I don't know.
I believe we'll try to share them out. I'll have to double check that, but typically we have. And it's also been recorded, I believe. Yeah.
Yeah, but if you want, I can share the slides if you want. Yeah, I can send it to you.
No more questions?
What percentage of would you estimate non-governmental organizations are actually aware of software bill of materials and are actually requesting it from, say, the entities you work with?
It is a very small, and yeah, that's why we have all this cluster truck issues with the log4j and things like that. So yeah, unfortunately, we don't speak enough about this.
Yep. I think one last question. We're about out of time.
Could I see the slide with the tools,
Uh-huh.
the list of tools real quick, just so I could snap a picture of it?
Oh yeah, sure.
Perfect, thank you.
Well, thank you so much. Thank you, Dmitry. Excellent.
Thank you.